You are about to embark on a journey into Schrodinger's hat, a place where science fact coexists with science fiction, a place where everything you see and hear is simultaneously real and completely made up. So settle down, relax, and enjoy your time in the capable hands of the Free Radicals!
Science!
So, batteries. I presume everyone here knows what a battery is. We use them for a lot of things. And you know, you heard of lead acid batteries and various other kinds of batteries. But when you hear lithium-ion battery, I think a lot of people don't realize really how complex and how different some of these batteries are. A lithium-ion battery, in one sense, if you pull it out of a device, is going to be a very different lithium-ion battery to something pulled out of another device. There's many different kinds of materials in a lithium-ion battery, and that's the subject of this talk. It's about the materials and what we're doing with things and where we're going with things. So, for example, in a lithium-ion battery, you can have some lithium in there, but it's almost never in an elemental form. It's usually intercalated into graphite material, mixed with a silicon as an alloy or other alloying elements. Or it could actually be as an elemental material, but there's some operating issues with trying to do that. The cathode, on the other hand, so that's the positive end of the battery, whereas the lithium or the intercalation graphite is the negative end. The cathode can be a range of different materials like lithium cobalt oxide, lithium iron phosphate, lithium cobalt phosphate. There's a whole range of different chemistries and there are different metals that are included in there. And the reason why we use some of these different metals are for different energy densities, different safety factors. So, for example, lithium iron phosphate is a really useful material, invented quite a long time ago. It has a reasonable amount of energy density, and that's a very common material that's in the cathode of your lithium-ion batteries. Lithium cobalt oxide is also one. And if you're not familiar, cobalt actually is a bit of a critical raw material, whereas iron's not. So that's why we're still using lithium iron phosphate instead of lithium cobalt oxide, despite the fact that lithium cobalt oxide actually has higher energy density, because cobalt doesn't actually come from anywhere you want. You can't dig in your back garden and find some cobalt. It actually comes from some really sensitive places where the sources of cobalt could actually be kind of difficult to obtain in a nice, consistent manner, or justly, if we should say. Shouldn't go into the ethical matters of cobalt itself, but because of that, there's actually a huge drive in the industry to try to remove cobalt from any batteries. And so this is where people are looking at things like nickel that goes in there. So you could have iron, you can have manganese, not magnesium, although those exist too. You could have cobalt and you can have nickel to try to drive up your energy density, because as you go through from iron, manganese, cobalt to nickel, you get the higher potentials of the cathode, which means you get more energy, because potential times current is basically your energy that you can get out of it. So when we move past cobalt to nickel, that's great, we can get higher voltage, but actually we also have an issue with stability of materials. As you get more performance out of things, sometimes you get less stability out of them. Sometimes physics is not always our friend. And to fight against these things, you have to do some really complicated design factors. So this could be things where you're actually working at the nanoscopic level of tailoring the way that things interface and coatings on things. You can tailor the way that things are crystallized. There's all sorts of different ways of mixing different elements to aid stability of them. So some people, for example, there's a lot of literature about trying to introduce fluorine into the system to offset the way that the redox behavior occurs. And so there's lots of stuff people are doing in the space to try to get a higher voltage, higher energy, but with a stable material. And that's because when you take another material, for example, lithium, nickel, cobalt, aluminium oxide, which is actually most commonly found in a Tesla battery, they have a high energy density, but they have some safety issues. They have a bit of an issue with running away thermally at relatively low temperatures. So for example, if you have an electrical short circuit, then that can cause rapid heating up because of a high current that goes through your battery. And people will be familiar with these things. hopefully none of you in here, with respect to the Samsung phone that had a lot of issues catching on fire. That was actually due to a short circuit problem. If you had more inherently safe battery itself, sometimes if you try to short circuit it, it actually wouldn't cause a problem. So NCA is not one of those types of materials. Relatively low temperatures, below 250 degrees C, you can start to get thermal runaway. The material starts to decompose, and then that can start to create gases from your electrolyte, and then you can get fires and explosions because it's actually flammable.
Same as electronic cigarettes that keep read about them blowing up in people's pockets.
I don't know what the batteries are in those, but yeah, smaller portable electronics like that actually can be made much more inherently safe, much more easily. And we're trying to take this technology and move it into larger bulk things, like to put it into cars. So this is where we use, instead of liquid electrolytes, which are flammable and can actually not only produce gases but explode, which usually for an explosion you have to go to much higher temperatures, and you'd have to have a lot of engineering to conceal everything, probably the wrong way for that to actually really occur. But you can move away from organic electrolytes to inorganic electrolytes, or otherwise known as solid-state batteries. These are already used for the Internet of Things, and they've been used for quite a long time in computer chips and small electronics. But we've been able to get away with materials, for example, the solid inorganic material that allows you to move lithium through the system, which has really low conductivities of lithium. So now we've started to discover materials that have higher conductivities of lithium that are actually much more inherently safe. They have a relatively low weight, and we can start to use them to make larger batteries, and so that we can take advantage of the energy density of some of these materials with some inherent safety factors built into that. And the other factor that helps with that as well is with the inorganic electrolyte, when you put together your system, you're not just making a single battery that goes into a car. You're making a battery that gets built into a pack of batteries and into a module setup, and then it has this control system built into it. There's a huge amount of sophisticated electronics that go in there, and includes supercapacitors to try to help with load leveling of it. So there's a lot of complex things that go into making a whole thing that fits into the car. So in one of these systems where you have an inorganic electrolyte, where it does have sufficient conductivity and does provide you with decent lifetime, because that's one of the issues we're working on at the moment, you can actually get away with packaging something which would normally be maybe 5 times the size of my body to something that might be 3 times the size of my body. Because you don't have to have all these peripheral aspects of the system to help control things. It's inherently safer and actually self-controlled in the process. So that's one of the things where we classify that in a space called beyond lithium ion, because it's a technology that we're moving past something which is the conventional liquid electrolyte lithium ion system, which we've known well for about 20 years or so, maybe much more actually. And we're moving to something which is very, very different kind of creature to work with, because there's a lot of mechanical aspects involved with things that are fully solid state. They can expand and contract when you're moving lithium in and out of them. And if you have something that moves from a volume, say silicon, when you alloy lithium with it, it can expand 350% its initial volume. So you can't use that very well in a solid system. It just crack open and it'll stop working. So there's a lot of things you have to be careful with the way that you actually design these, the materials that you develop for them. But sometimes you might want to actually try to go to the ultimate end of designing a battery. And the greatest energy density that you can actually get out of a known theoretical battery concept is a lithium air battery. And that effectively just uses lithium metal on the anode, and it uses really lightweight material like carbon, for example, on the cathode, and then it sequesters oxygen from the atmosphere, and it makes lithium peroxide, or if in an aqueous system, it makes lithium hydroxide. But those have some issues. Water and lithium tends to cause fires, so not too many people are trying to go forward with that. But in an inorganic system, you might be able to do this, but actually, people have been trying to work on this for almost 10 years, and we still have no idea whether it's even feasible, because there's a lot of critical issues with that one. So the inorganic electrolyte can actually degrade in the presence of the electrochemical processes that you're driving. The carbon or other materials that you might use on the cathode, they themselves can also degrade in that process. And the reason why we aren't using lithium metal the world around at the moment as an anode is because when you try to charge it, it doesn't charge to a nice thin plated material, nice and reversibly. When you try to put a lithium back onto the anode side, it actually can easily form dendrites, like trees that grow out of it, and then they'll create electrical short circuits, causing potential fires. So there's a lot of interesting design aspects where you're trying to go all the way from something that works and that we can start to use to advance our technologies to something which is going to be completely systemic in many, many devices and trying to help us move to something which is just a much more environmentally friendly and sustainable planet. So this kind of all works in the space of what is referred to as the energy trilemma. So you're trying to reduce your CO2 emissions in every way that you can possibly, while trying to make sure that you have energy security and providing energy to people at the lowest cost possible. And trying to do all those things and simultaneously paying attention to the safety of materials and how to actually construct these things, as I mentioned, down to the nanoscopic level to make sure that you have providing the performance while providing the safety and stability is a real critical thing that we try to do.
We need to add someone nitrogen.
Ooh, be careful.
It has to crystallize properly.
No, but I'm not sure who's going to win the cook-off.
Well, yes, you always do the best candy.
But this is really important. It's got to have the right thermal structure. I don't want it being too hot for when the judges taste it.
Have you properly, you put it in at 160, right?
What units?
Centigrade.
Centigrade?
Yeah?
You can't use that at 160 centigrade. It's going into a child's toy.
A child's toy?
It's a speak and spell. They'll burn their little fingers.
Okay, right. We can fix this. We can fix this.
Look, the only thing that's going to get that past the judges. Cobalt.
We said we'd never use cobalt again.
Meanwhile, deep in the cobalt mines.
I hope it's off to code.
Do you ever stop to think? Whether mining cobalt is right?
Yeah, I'll do fucking things sometimes. Cobalt this. Cobalt that. And then I realise how much I'm getting paid. And then I'll keep mining.
I wish they didn't pay us by the ton.
You get paid by the ton.
Yeah.
I get paid by the axe. And each time I hit the axe, the pickaxe, I get money.
What?
See? Yeah.
I've been doing this for 3 years. I've got 350 kilos.
Oh,
I haven't been paid yet.
I've been paid a lot. I get like £500 per whack.
Meanwhile, in the accounts department, I don't get this. That worker's being paid way too much. His productivity is absolutely terrible.
Yeah, but have you seen him? I mean, what?
I'm sorry, they're not the kind of figures I'm interested in.
Have you not? Let me show you my calendar. Look at January.
There are only 30 days on that calendar.
It's fine.
No, look below. Look, eyes down. Look, there's only 30 days. Where did you get that printed?
I'd made it myself. Look at February.
29. It's not a leap year.
Oh, it's a leap year when I look at it. You want to look at this one?
I tell you what I want to do is recheck your figures. No wonder we're making a loss at the mine.
I'll get 1999s out then. Huh? Eh?
I see.
Are you suffering from low energy density? Then you need new What Aid. High in inorganic electrolytes. Just swallow it down and your lithium will be sequestering oxygen in no time.
Can I have it? But I'm pathetic. Give it-
Drink this, Colin.
Okay.
Ah, yes.
My God. Look at me.
What Aid? If you need energy density, we've got it for you.
And that's why I've got all of them on video. That's one of his videos. Oh my God! Hi, Colin.
Hey.
Managed to make it to management then?
Yeah, I gave him a promotion.
Ah, okay. Yeah, I can totally see why.
So can
But
I.
shouldn't we,
Can I have a copy?
I go to my office.
Yeah, it's the big one over there. Yeah.
see a
Colin,
Yeah.
come back.
Yeah.
Oh, I've forgotten. It's all right. You can go back to your office now.
Dropped your pen.
Oh, of course.
Well, that was
Can I be excused, please?
Yep.
I think I'll go right now too.
And that's the end of that. Perhaps. Yes.
Mm-hmm.
Quite.
Yeah. No, I agree.
I think you're right.
17.
Yeah. What?
What?
17?
Yeah.
I thought it was 19. That is a prime and all, but 17?
What's a prime?
Well, really? You won the Fields Medal and you don't know what a prime is?
I'm testing you to make sure you know what a prime is.
Oh.
What's a prime?
Okay. A prime is a number that can only be divided by two numbers, 1 and it's...
Exactly, that is correct.
Oh, thank you.
That is a good number.
Contestants, 1 hour until judging. 1 hour.
Okay. So, you think 17, not 19?
Yeah. Yeah. 17. 17 batteries.
Not 19.
No.
17.
No.
What configuration?
Standard 2 at the front, 4 in the middle, 4 at the back. And then we have 7 more.
So you think more Christmas tree?
I think Christmas tree mixed with like an arrow.
Yes. Yes. We should,
Yeah.
we'll focus the energy to a point,
Yes,
pass it
yeah.
into a supercapacitor, and
Uh-huh.
smooth out the
I
signal.
like that.
Okay, so 160 obviously is too high of a threshold.
Okay,
If we
fine.
get it to 50, I think probably with cups, that would probably work.
From 160 to 50. Okay, right, we can do this. So, with the cobalt. it'll-
Alright lads, how are you getting on?
It's okay,
it's fine.
Yes.
yes.
You'll be avoiding the electronic soggy bottom, will you?
No, of course not. You know, who would want a soggy bottom, right?
Oh, okay. You
We're
have to be worried
sequestering
there.
from the air, so no
From the
saltiness
air,
in
okay.
this one.
You're not combining water and lithium, are you?
Oh,
No, we
no,
wouldn't do that.
Combining
Well,
water
we'll
and
just use-
lithium is quite a basic error, and our amateurs would do best not to do that, especially in such a flammable tent.
It's not. You know, we'll use nitrogen instead.
Nitrogen, interesting.
Yes.
I like using nitrogen to get my rocks off at the weekend. But let's go on to the next contestants.
Okay, right. Like nitrogen, cobalt, candy.
We're going to have to find an alternative. I'm just thinking. I mean,
Okay.
we use tar. Tar instead of.
The energy density will be too low, right?
Yeah, but it will retain the heat better than cobalt. Maybe easier to shape. We need to have a case that actually holds the charge.
Okay, fine. We'll use tar.
Okay.
Let's get into it.
Lads,
Yeah?
I've got a trilemma.
Okay.
I want to get into that vault,
Oh, yeah?
but I want to get into that vault.
Oh!
But I've only got one drill.
Oh! Why you got to decide which phone you're going to?
Yeah. To work out exactly how much power, I've got to figure out its potential and how many volts I got.
Oh, yeah. I see we did that.
Really? Explain it.
30 minutes later.
And that's why.
Touche. Well, we've got 10 minutes left now. Thank you very much for that. You could have done power equals current by this one or that one?
Oh, you got that one.
All right.
Do it right. What?
All right.
You're either Dave, helping out. Yeah? Contributing. Can I have a Twinkie?
No.
Oh, okay.
Go on, explain resistance for us. In terms of potential and current.
1 hour, 20 minutes
Oh, that was very good. Make me laugh. Oh.
We've overrun by an hour 20.
Oh, I thought everyone would go home.
We have. We're a mirage.
We lost it.
Yeah, it's so hot in here. He's a palm tree.
It looks like a dendril to me.
Okay, so the tar works, but it's growing dendrites. When it's discharging, it's growing dendrites. It looks like trees. It's quite pretty, I guess.
But it's going to hurt their little fingers.
Yes.
We'll be on watchdogs.
Meanwhile, on Watchdog.
And tonight we have a breaking story where a new battery that's being released by the Soggy Bottom Company is hurting the children who are trying to use it. This has been a most very terrible disaster for Soggy Bottom Company. We have our representative tonight, CEO Alex Alvin. Do you have anything to say, sir?
Soggy bombs are not allowed in the company due to I can't do it anymore. We cocked up really badly, and 3 people are dead.
You heard it here first. Thank you and good night.
Back to the competition.
Well, maybe
This is a disaster. We can't use this anymore.
What about an executive toy? We can just put it on the desk and it's like a little kind of battery garden.
A battery garden. I
Yes.
like the idea of that.
You know.
We have to encase it. We have to put it in glass. We have to make sure it's isolated from the environment. And then, yeah.
We can put like sea monkeys in there. And water.
Let's start with just something that grows dendrites, shall we?
I'm terribly sorry, Doctor. I'm terribly sorry. Are you holding a pickaxe? I'm terribly sorry, Doctor. I tried to put it back in, but my cathode has fallen out.
It's okay.
Should I put it back in the animal?
No, I'll put it back in. The pickaxe uses to scare the children.
Good. Good?
Yeah,
Good.
to scare them and they never do it again. If you say you do that again, you get a pickaxe in you, they don't do it again. So, Cather's popped down again.
Yes.
Oh my God. God, you made a mess down here, haven't you?
Yes, a positive mess.
Okay. Well, let's try and connect you back up to what we had before.
Yeah, in the anode.
Yeah. Okay.
It tingles, Doctor.
Well, it would do. It would do. Now, I probably should put a glove on first. I'll put one on now. Seal it in. Well done. Great job.
Thank you very much, sir.
Lovely.
I'll enjoy this at home. Oh, the books are in a mess.
Yes, but we have Colin, so, who cares?
Well, I've got a wife and 2 kids to support. I need my pension payments.
You didn't seem too concerned yesterday.
Yeah, but that was a nice picture.
It was.
Gareth, for goodness
What?
sake.
It's okay, it's fine.
It's not fine.
Why do you think I put a shower in the ballroom for?
I'm going to have to report this to head office.
Yeah, I'm going to report to head office as well.
This is serious, guys.
Yeah, look at the zoom.
Whoa, too much.
That is too much.
Oh, Jesus.
Oh, what's that tattoo?
Yeah.
It's Nobel Peace Prize. It's got a picture of a bell with a cross it. That's quite funny. Nobel Peace Prize. It's quite good actually.
Hey,
No hot iron.
Probably.
are you going to turn these into calendars again? Because I really want one.
Yeah, sure. I'll laminate this one.
Meanwhile, back at the cobalt face. 355 kilos.
120,000 pounds. 120,000 pounds, 500. Big day today.
Really? Why is it a big day?
121,000 pounds. A lot of money.
It is a lot of money.
How much money have you got?
None yet.
Oh, unfortunate.
I've still
Also
got...
mine.
Oh, yes?
Work for me.
Have some cobalt.
Ah! My God, I'm a multi-millionaire. Thanks.
Oh. Wait.
Do you know what? I'm going to buy one of these automatic pickaxe things that just keeps going back and forth loads of time.
Is that ethical?
Probably.
It's stabilized.
It's quite pretty.
Amazing, by putting that iron in there and that silicon, we've stabilized the product.
It's a mixture of old tech and new tech. Old lithium ion and beyond lithium ion.
We're going to do away with the need for cobalt completely. Imagine what's going to happen to the cobalt market when this gets out.
We'll be multi-millionaires.
Also, the environment, all those cruel things, they're not going to stop. They're going to stop.
We've just...
Those slaves in the miners are going to be free.
Well, yes, I guess. When do we go to market?
Well, we'll win this competition first.
Yeah.
We need
Congratulations, you've won.
We've just solved a problem, a worldwide problem. There's no more need for cobalt.
I'm going to meet Mary Berry, though.
Those bastards have done us out of a job!
Oh no.
I never got paid. 357 kilos I got to. Do you know how short that is of a ton?
I don't know, 643.
Yeah, right. Every now and then you surprise me.
I have my moments.
Infrequently.
Yeah, it is true, but
Anyway, they've done us out of a job.
oh, well, I'll probably go and purchase something. Maybe, I don't know, maybe I'll go into insurance. This is quite, I don't know, or maybe stuffing. I don't know, I'm just trying to think of ideas, brainstorming. Give me a few.
I'm gonna end it all. I've got my nickel cadmium battery here. I'm gonna end it all.
Go on.
Did I hear you might be looking for work? I've got this franchise that perhaps you might be interested in. You can work from home selling energy drinks.
Never! Oh, it's run out of power. Bloody NiCad batteries.
What aid franchise?
All right then.
Be rich, working for your own home, ringing people up, annoying them.
How does it work?
I just told you.
Honey, how was your day then? I hope you've, got to get closer to the ton now.
No. I've been put out of a job by two men. One who's older and one who looks suspiciously like you, Gary.
No relation, I'm sure.
I hope not, because now I've been forced to become a telemarketer. What? Exactly. What? What aid?
Oh no. Well,
I can replace electrolytes inorganically.
we should try the product.
But it's so metally.
It is very shiny. But does that come through when you call people up?
Yes, it does, because the quality of what aid speaks for itself. Oh!
I'm so proud of you. James, you can do this. I know you can.
I just had an absence. What just happened?
You just sold what aid?
But I only went on the training course for 7 days, and I remember a minute of it. Lunch.
You don't need to remember on it. You just need to get on that phone and sell what aid.
Sell what aid? Of course I'll sell what aid. You'll have one, won't you have one? I'll never stop going because I'm powered with what aid. Can we survive this?
I don't know, but we'll try.
10 years later.
Can we still survive this? A
10 years
decade,
later.
2 decades more of this. My back kills me. I've been on the phone so long, but I never remember what I say.
No, but we survive. And there's the £10,000 worth of what aid that you've sold already in the storeroom that we still have to get through.
Are you low on energy, darling?
No, don't do this to me. Don't do this to me,
You
James.
might need to replace your electrolytes with an inorganic electrolyte.
You've got to control yourself.
Take some, darling. You know you want to.
They were such a lovely couple. Who'd have thought? There was a whole room full of that stuff.
Just didn't stop, did they?
The company went out of business 6 years ago.
Would anybody like a cake?
I made a banana loaf.
Would anybody like a cake? Banana loaf, Francine, does not count as cake.
Well-
We've gone through this already.
Why not?
Why not? What is it called again? Banana loaf. The word cake is
Or
on it.
bread, banana bread.
Oh my god, you're making it worse.
Yeah, but then you've got like...
Cake?
you've
What
got-
sort of cake?
I've got cream cakes, fairy cakes, I've even got Jaffa cakes. But no
Jaffa cakes and biscuits.
banana bread. I think you'll find, because of VAT, Jaffa cakes are cakes.
Oh.
Just this once, I'll take your word for it.
The only thing I do know is going on today is that is correct. How's your banana loaf?
Very nice.
Really?
It's one of my favourite loaves ever.
And that's why he left you.
Yeah.
Why did you bring that up again?
Back to the breakup. Stop eating that banana loaf, or I'll leave you.
No! Well, I like it.
Stop eating it, or I'll leave you. I promise I will this time.
No! Just have a bit. Go on, have a bit.
You disgust.
Go on, I've got walnuts in it this time.
You disgust me.
Oh no, don't.
Do you remember the combination for the suitcase?
I don't know, 1, 2, 3?
Yeah, that's got it. I'm leaving you.
Oh no, I gave it away.
Damned banana loaf. Goodbye.
And that's what happened.
Cheers for reminding me. I'm just gonna go end it now. I don't know. I'll do something off stage. It'll be deadly.
Brilliant. Now that she's gone.
Well, so since you left the job at the mines, the accounts department just collapsed around you, and they found all those calendars in your bottom drawer.
Yeah. I had 32 years worth of the same picture. It's like a flip book.
You only worked there for 5 years.
Yep. Go figure.
You were the reason that company failed. Do you know that?
You can't blame me for it.
Their accounts were absolutely shot.
Yeah, but did you not see how hot he was? He was like Prince Charming with a mix of Hercules with a small, slightly tiny, small
It was a
dance
prime
moves of Wayne Sleep.
It was a prime number, the golden ratio. That's what was so nice about him. I know.
Whatever, numbers. All I know that I would definitely give him one.
How did you get that job with a GCSE in art?
GCSE? No GCSEs.
What was it then?
I just did a dance.
You got the head of accounts in that firm for dancing.
Yeah. Oh no, I was a dancer in a club. I spotted him. I knew where he worked. I blackmailed him. That's how I got the job.
Because I was going to ask you to do the dance.
I can't anymore.
I know it's okay. You explained it in such a way that I know I don't have to ask you about dancing.
You're welcome. You're welcome.
I don't know what happens these days. So what are you doing now?
So that was a great prototype. Yeah.
Thank you, Sir Calvin. I'm really excited by our progress in the.
Look me in the eye. There we go. Good eye contact. Social skills are down.
Okay.
Good.
Yeah,
Shoulders back. There we go. Hands on your pocket.
The cobalt, sir. The cobaltless
Yes.
battery.
Yes.
It's coming along very well, sir.
Good.
Yes. Have I mentioned that you look very similar to a calendar that I once got? It's kind of
What kind of calendar are you talking about?
I don't know. Well, it's got all the wrong dates in it, but
Yeah.
it looks like you. It really does.
Uh-huh.
Oh yeah, that was it. That pose. Oh my god. Oh my god.
And we'll leave it there. Thank you very much.